You may have seen my video from last June, where I dug up a 20-year-old copy of Pokemon Blue that still had my save file intact. Sadly, a lot of Gen 1 and 2 Pokemon games nowadays have run out of juice, and the only way to fix this is by changing the internal battery. This is a very beginner-friendly project, so don't be too daunted. The bare essentials are as follows: a Game Boy or Game Boy Color game cartridge with a dead internal battery, a Game Boy system to test and verify your file, a 3.8mm security GameBit or GameBit Screwdriver. Unless you want to half-ass this, you're going to need a soldering iron. Mine is a 60-watt temperature-controlled iron set to about 340 degrees. Some soldering wire of your choice. A 6040 Rosin core is what I'll be using here, but leaded wire is available if you see fit. This one is 0.8mm in diameter. Most importantly, you'll need a CR2025 or CR1616 battery. When you buy a battery, make sure it comes pre-tabbed like this, otherwise you won't be able to join it to the board. Although not 100% necessary, you should also consider getting some isopropyl alcohol and some cotton buds. The higher the alcohol content, the quicker it dries. Some desoldering braid. This is used to soak up any unfortunate mistakes that you or the previous owners have made. ESD-safe non-magnetic needle nose tweezers. I quite like these curved ones. You can do this whole process without them if you're careful, but it can be useful to get some leverage on the battery while keeping your fingers away from the heat. A brass wire coil to clean the tip of your iron between uses. You can also use a slightly damp sponge if you like, but I think this is the better option. And last but not least, a silicone mat. This is simply a heat-resistant mat that will keep your desk from getting burnt or dirty. Disclaimer, remember that you will lose any existing save files unless you back them up now. First of all, we're going to use our 3.8mm GameBit Screwdriver to undo the security screw on the back of the case. Once it's out, put it somewhere safe. My silicone mat has handy little compartments to hold various bits and pieces. Next, slide the front cover downwards and then away from the rear housing to expose the printed circuit board. The board itself isn't held in place by anything else, so gently pop it out and set it onto your work surface. The battery is on the top right hand corner of the PCB, and somewhere above it in gold text will be the details. Mine's a CR2025, and that's what I'll be using to replace it with, but yours may say CR1616 or even CR2032. Pay attention to the positive and minus signs besides the pads so that we can connect the new battery to the correct polarity. If your iron isn't hot already, now's the time to heat it up. I found 340 degrees to be a perfectly adequate heat for this kind of work. The idea is to be in and out as quickly as possible to prevent damaging the circuit board, and anything below 340 degrees can be a bit inefficient. Before we get started properly, we're going to tin both sides of the new battery tabs. This will help us form a solid joint when we attach it to the board. The trick is to heat the metal tabs with the iron and then keep feeding the wire into the tab. If you use too little, then you won't get enough coverage. We want a solid, shiny blob covering both sides of each hole. You can also try tinning the tip of your iron in order to aid in heat transfer. You do this by applying a small blob of solder onto the iron's tip once it's fully heated. I recommend doing this step early on because it's hard to mess up and hopefully it will give you some confidence before you touch the more delicate parts. By the way, make sure you place your soldering iron back into its stand between uses and don't leave it unattended. You should also make sure you're working in a well-ventilated space or have an extractor fan nearby to remove any smoke or fumes. Use your head. Next, we're going to free the old battery from the board. Here's where you can use your helping hands if you like, or tweezers like I am. But if you're careful, it's entirely possible to use your fingers alone. Either way, be careful of the heat. I'm using these curved tweezers to provide gentle leverage beneath the lower tab so that when I heat the solder up it lifts off cleanly. We're not trying to pry or snap it off like a crowbar, we're just letting the heat do the work for us. When the temperature is right, we can be in and out in about 2 seconds. Pay attention to the orientation of the tabs. It's much easier to pry the lower tab upward from the board first than it is to do it the other way around. From there, repeat the process to free up the opposite tab. I found it easier to use my fingers here for finer control, but it's up to you. If the remaining solder looks excessively messy, then pass the iron back over it in a circular motion to flatten it out. Take care when applying the fresh battery so that it sits neatly into the guidelines, and make sure that the correct polarity is maintained. The positive side's tabs go to the positive pad and the negative to the negative. If I push down gently against the battery while heating the joint, it will rest flush against the board. This can be more important when using bigger batteries like the CR2032, as the case still needs to fit around it. Providing you've pre-tinned your tabs, then you shouldn't need to add any additional solder, although remember that tinning the tip of your iron will help in heat transference. Congrats, the hard part is done. If all has gone well, you should end up with some flat, shiny joints that keep a solid connection for years to come. While the board is still exposed, you might want to take a moment to clean off any remaining flux with isopropyl alcohol, and scrub down the connecting pins. A soft cotton bud will do the trick, but I've heard that a pencil eraser can work especially well on dirty pins too. Place the board back inside the case the same way that it went in, and retighten the GameBit screw. Hopefully you kept yours safe. The last thing to do is to test your work, so load up the game and start a new save file. After reaching a point early on, save the game and switch off the system. We need to wait a moment to ensure that any residual power has cleared the board before loading it back up. If your new save file is still intact, then great, you've done a solid job and you're free to catch Pokemon to your heart's content. In the event that your game's failed to save, I suggest double checking that your battery is fresh and that you've connected it via the correct polarity. Best of luck. I hope this encourages you to resurrect some old games and learn a new skill along the way. As always, thank you so much for watching, and I hope to see you next time for more Game Boy mods, sculptures, and Bandai model kits. See you next time.